All right, all your floor. Go ahead.
All right, thank you, thank you. Well, first of all, thank you, Yuri, Lariana, Gustavo, Wellington, everybody for having us on. My name is Jussi. I am the wireless janitor here at Hamina. And if you're curious to know more, just go to hamina.com. I hope you can see my screen. Hey, Joel, how are you, man?
I'm doing pretty good. Other than it being really early, I'm great and very excited to be here.
Excellent. And what do you do at Hamina?
All kinds of stuff. I help you out with product a little bit. I answer lots of emails. I do lots of demos for people. A little bit of product development here and there, some marketing. It's all over the place.
All good though. I was thinking, since it's still early for you, should we start light and talk a little bit about like what 6 GHz brings from like the network design perspective? Kind of ultimately, we probably want to answer like what considerations should I take with 6 GHz Wi-Fi and Wi-Fi 6E? But before that, or kind of in preparation for that, we should probably talk about signal propagation on the 6 GHz space, right? So can you see my screen, Joel?
I can see all your scribbles. They look great.
Excellent. So I mean, if we look at 2.4, right, there's certain free space propagation to it, and then there's 5 GHz, which is somewhat, this difference is significant, right? The difference between 2.4 and 5 at decent distances, correct?
Yes. Yeah, there is a fairly big difference between how 2.4 and 5 gigahertz propagate. But what about 6 gigahertz UC? Does UC or does 6 gigahertz propagate differently? Does UC propagate differently? You could tell it's early.
So I mean, it's not that far from 5 GHz, right? The upper side of upper 5 GHz, certainly Uni 4, but even Uni 3, all of that, it's kind of upper part of 5 and lower part of 6 are almost touching one another. Not quite, but almost, right? So they are pretty close. That's kind of what I tried to illustrate in this picture. So it's pretty darn close. So there isn't a humongous difference. Now, mind you, 6 GHz is a full gigahertz of space in the US, some other countries too, but in Europe it's the lowest 500 megahertz for now. But I mean, there is a difference, but it's not free space difference isn't nearly as vast as between 2, 4, and 5. So you probably, if it was only for the free space, we probably wouldn't need to consider that as much. But what if we add walls to the equation to make things a bit more challenging, Joel? I don't know if you've ever like seen my scribbles and stuff like that, except when we rehearsed this extensively 20 times before this presentation.
Yes, the extensive stuff that we did to prepare. Yes, I have seen that there is a fair bit of a difference when you introduce things like walls, doors, warehouse shelving, things like that. Those do seem to make a fairly big difference for 6 gigahertz.
Yeah, exactly, and certainly for between 2, 4, and 5. This difference here, the free space difference is already quite significant. And then the difference may become bigger as you introduce different kinds of walls into the equation. And with 6 gigahertz, I'm just going to do this highly scientific draw out here. This difference is still, the free space difference, again, isn't that dramatic, but how much of a difference there is between 5 and 6 gigahertz when penetrating the walls, that's then a good question, right? And that's wall material dependent. Kind of the difference in how 5 gigahertz signals are blocked or attenuated and how 6 gigahertz signals are attenuated when they go through walls. There is some difference, and that varies on the wall material type. Luckily, for the classic wall materials that are the most common, like drywall and stuff like that, 5 and 6 gigahertz behave quite similarly. But for some of the stronger materials and more exotic materials, like very thick glass and certainly concrete and stuff like that, the difference between 5 gigahertz penetration and 6 gigahertz penetration through those walls actually may play some role in the equation. So you definitely want to also these days at least design for 6 gigahertz, using predictives, just to make sure that you're on the same page, on the correct page. But when you design for 5 gigahertz, I wouldn't see it as a humongous risk, to be honest, today. Your 6 gigahertz is pretty likely, is very likely to work at least decently. What would you say, Joel?
Yeah, I agree. I think the propagation is close enough that you're probably going to get some basic level of connectivity out of it. It might not be perfect. You might have a couple little, I wouldn't say dead spots, but maybe a few places that are a bit weaker. But overall, so far, we're finding it's pretty early to really know for sure with 6 gigahertz. But so far, we're finding that the propagation is not super different.
Exactly. It may come more into play with uplink. And this is actually a good topic for the next MBC, for example. We should talk about the uplink signal differences, because usually we're looking at downlink from AP to client. But what if we switch that so that we're talking from client to AP? And then there's all the like, is it standard power? Is it not? All these kind of things come into play, and the whole standard power equation is kind of still figuring itself out. So that's definitely a good topic, maybe for a future talk as well. One thing I still wanted to bring up is that makes, of course, affects the signal behavior and eventually then also affects your design decisions, is how the AP radiates, right? Because the AP radiation patterns are quite different, and they are different in different frequencies for the different radios and different antennas for different frequencies. Is that fair to say, Joel?
Yeah, I think you're going to see fairly different patterns, and it's going to depend fairly significantly on the access point, but it is a different antenna. It is going to create a wildly different shape, which means we need 6 gigahertz specific tools that support 6 gigahertz for this to be calculated correctly.
Exactly. And here at Hamina, we put a lot of emphasis to make the antennas look like tomatoes or pumpkins. No, this is really how, for example, the Aruba 630 looks. What we saw first, the tomato looking was 2.4, this was 5, and this is 6 gigahertz, which seems to be a little bit of Apple looking coincidentally. And this is somewhere between Apple and a pumpkin. And then if we look at Bluetooth, the Bluetooth radio, that actually does look quite a bit like an Apple. But we put a lot of care, and we've talked about this with Aruba's, Arad. I was going to say Arad. Maybe that's Anno and Jared together. They're product managers in the same group. So we've talked with Arad, hashtag Aruba Arad, to kind of fine tune the system so that the vendors are fairly represented, but also that each of the antenna is fairly represented, so that the results from your planning are compatible, whether you're using vendor A or vendor C or vendor M or whatever you're using. And that involves like highly accurately kind of 3D designing the antennas and stuff like that. And that's what you're seeing here as well. Hey, Joel, I forgot to ask, is there some kind of a chat functionality here that people have to kind of communicate with us as well during the presentation?
Yeah, there is actually. There's a chat function. There's a chat function built into the YouTube stream, and I've been chatting it up with our friend Nick Turner, who's asking questions about what kind of fruit it was.
You're chatting up with Nick Turner every day, day in and day out.
Basically, yeah, and I'm good with that. I like it that way. But yeah, for everyone that's listening, if you have any questions, comments, anything like that, please feel free to use the YouTube chat. The stream is going to be a couple minutes behind, so it'll take us a minute or two before we respond to your question or your comment, but I'm definitely keeping an eye on that, so feel free to engage in there.
Does it support like simultaneous translation, Spanish to English?
It does not, but I'm throwing things into Google Translate. So anyone, feel free to just ask your question in your native language, and I'll just throw it into Google Translate so we can communicate that way.
Excellent, excellent. Should we take a look at some practical examples of 6 gigahertz design then?
Yes.
While you chat, I don't want to interrupt your chat with Nick Turner, but
oh, thank you. Yeah, that's okay. Go ahead and show some examples. I'll continue to chat with Nick over on the side here.
Tell Nick I said hi.
I will.
Okay, so should we start by making a simple illustration of a soccer field, and then we go from there? Joel, do you know what soccer is?
Yeah, well, we call it soccer here, but I think in most places it's called football, right?
Yeah, man.
Right. I've been watching Ted Lasso, so I'm learning all about it right now.
Excellent. Good choice for a TV show as well.
Thanks.
So yeah. Let's put up a soccer field, and I don't know. I will probably be butchered because this is a Brazilian conference, and I totally should know this. But let's say a soccer field's length is 105 meters. Feel free to butcher me on the chat board if you would like. I'm just gonna say that's roughly what that is. And now let's take a look at some practical differences for pretty much the AP that we saw there. So I'm just gonna take, let's say, an Aruba 615, and I'm gonna put that into all of these I'm going to put into the same transmit power. So 2.45 gig and 6 gig operating on the same TX power. I'm going to put it into an L mount at 2 meters height. And then I will be placing that on the map. And let's see how that ends up looking like. Gonna look at the Wi-Fi coverage. Okay, so right now 5 gigahertz. So flipping to 2.4. 2.4, again, significant difference between 2.4 and 5. 2.4, of course, being a lot louder than 5. And then let's flip back between 5 and 6. So 6 is less, 5 is slightly more. This is kind of what we try to illustrate as well. 6 is a little less, 5 is a little more. Joel, what do you think? Is this pretty much what you expected to see?
Yeah, this is pretty much what I expected. And also, I love the hack of using a football field to look and see what things are going to look like in free space, what free space path loss is going to look like. I also will use open spaces like this to look at the antenna patterns, because right now you've just got an open space, you've placed the access point in there, and it's just showing us free space path loss. That's all we're seeing right now. That is a fantastic way to understand what the AP is going to do and what the propagation is going to look like in the environment. So I do that all the time, and I really enjoy doing that.
Now, remember how these are like a little bit donut shaped, like antennas normally are, right? I hope you can see my screen. But given the donut shape, let's try and lift this antenna up a little bit just to see what it does. So we'll put it to 25 meters. We'll lengthen the pole. I think only Ferney has, this length of AP poles in his inventory. But check out what we got here now. Actually, right below the AP, the signal starts getting worse. And obviously here, where the donut pattern would provide the strongest signal, we have the green, and then it fades away again. This also, I think it makes perfect sense. Are we seeing the same on 2.4? 2.4 still touches the ground quite okay because that penetrated better. 6 gigahertz doesn't even give you any green on the ground anymore. So yeah, that's just an example of how the height of the AP can play a pretty major difference. Maybe this is why you don't put donut pattern antennas on the warehouse ceilings and stuff like that, although you see that kind of stuff all the time. But this is maybe a way to illustrate why that's not a good idea.
Yeah. Hey, and we've got a question in the chat from Korea. Korea asks, what is the channel width that we're using here? What channel width are we using?
That's a great question. What we were using is the typical channel width. And remember, we're looking at signal strength. We're not looking at SNR. So I don't think channel width plays a role here. It would play a role if we looked at SNR, right? But with signal strength, I don't think it does. So on 2.4, we were obviously, there isn't even a choice in our tool. That was 20 megahertz, 5 gigahertz, 40, and then 6 gigahertz, that was 80. Okay.
Nice. Thank you.
And for us, when you're designing, just in our tool, it doesn't make a difference whether you choose channel 1 or 6 or 11, for example, on 2.4. The propagation will be the same. So we always take kind of the center frequency of that frequency band, because you never know what channel RRM is going to give you. So we just kind of propagate the signals based on the center frequency. But of course, the channels start to play a role when we calculate interference and things of that nature. I don't know if that explanation made any sense, but I hope it did. Okay, should we quickly build like an indoor building, see what happens between 2, 4, 5, and 6, and then maybe look at, I don't know, a warehouse or something like that? What do you think, Joel?
Yeah, I think so. What were you thinking of, like starting with a carpeted space or something like that? What kind of environment did you have in mind?
Why not? Why not? Like I don't know, a residential building, carpeted space, office building, something like that.
Yeah, kind of your typical Wi-Fi environment.
Yeah, exactly. So this would be like maybe office, mostly rooms type of a scenario. And what the environment type allows us to do is kind of like, if you don't do any walls, it will still do some kind of a guess on the signal range. We can show that too. What I'm gonna do is I'm just gonna put in a apartment building PDF here. And just wait for it to be processed. Joel, can you still hear me?
I sure can. Yeah, sorry.
Perfect.
I was Corey was asking some further questions about 6 gigahertz in the chat, so I was working on a response there. Corey was asking about the channel width that's used because of the transmit power, the transmit power compensation for wider channels. So one thing, I don't remember the exact details about how that works. I need to spend a little bit more time researching 6 gigahertz and really getting familiar with it. But if I remember correctly, unlike the 5 gigahertz band, where when we go to a wider channel, we have to spread out that transmit power across that wider channel. And so you end up, when you're doing transmissions with wider channels, you end up having less signal strength and less SNR. However, my understanding of that is that it only affects the data frames that are going across. Your management frames, your control frames, all that management overhead is still going to happen at 20 megahertz on the 20 megahertz wide channel. And so at the end of the day, when you're doing like a network design and you're thinking about channel widths, I don't know that it really makes a huge difference because the client can always fall back to a 20 megahertz wide channel as well. And I see that all the time on spectrum analyzers and packet analyzers. 6 gigahertz is a bit different though. With 6 gigahertz, we actually get to up our transmit power as we use more and more of the channels. So if we use an 80 megahertz wide channel or something like that, we actually get to increase our transmit power. I don't remember if that's everywhere, and I don't remember what the exact numbers are on that, although I'm sure that's a quick Google search away to find that out. So great question, Coria. Thank you for asking that. I appreciate that a lot. Sorry, I don't have a more concrete answer for you off the top of my head.
Excellent. And so in my demo environment, I pulled up a floor plan here, and now let's pull up some walls for the plan as well. So I'm just going to say import some of those walls. Gonna click on some of them. What do you think? Drywall, we can modify these later as well. Not right now, it's 3 dB all the way to the ceiling. We can modify those. This looks like a window. I'm gonna put some doors in there, and there we go. Okay, that's starting to look decent for a floor plan. I don't know how quickly this updates to you, by the way.
It's really smooth and really fast. So yeah, it's actually pretty much
Wow.
it's almost full strength on the video
Excellent.
stream. Yeah, StreamYard does a good job. They do pretty good.
Excellent. So I put in the walls. Here they are, kind of imported. It took it a few seconds to import the walls. We could import more as well, but let's say we are happy with these. Maybe we want to modify some of the walls a little bit. For example, like I know that there's heavier concrete walls in here. I could just paint them over and say that's actually concrete. That's easily changed. So you can see that change there. Okay. We are good to start designing the network and observe the kind of differences. So to look at the differences, let's take the same AP 615, and then we'll put it to the ceiling mount. This is what we used on the soccer field as well. So I'm going to say Wi-Fi coverage for 5 gigahertz. And Joel, what do you think? This is a tough one. I was thinking the other day, what do you think if we're partially doing 6 gigahertz capable APs and some of our APs are actually, non 6 gigahertz capable? Should we then just design for 5 gigahertz, or how should we do it?
Yeah, you probably do want to just design for 5 gigahertz in that case. I am very hesitant about doing a network that's like partially 6 gigahertz capable and partially non 6 gigahertz capable. It just feels odd to me to mix that in the environment. But so what I will probably do is designate certain parts of the building where we have 6 gigahertz in these parts of the building, and then in this part of the building, this part we don't have any 6 gigahertz support. I think that would be okay, because that helps set the expectation for the user of what quality of service they're going to receive. And this part we have fast new spectrum available. In this part, we only have the 5 gigahertz spectrum. I say only as if that's a bad thing, but 5 gigahertz I think is still super viable in most environments and still going to provide a good experience.
This is true. However, if I wanted extra capacity in like lecture hall, stuff like that, I would certainly entertain the idea of going 6 in the lecture halls and stuff like that. Of course, there's the like outside of the scope of this presentation is the SSID selections and WPA3 concerns, client device support, and all of that. But as an idea and as a concept, it's not that foreign to me. I could probably do that. So now I placed a few of the APs, and let's look at the differences between 2, 4, 5, and 6 in a second. What I'll just do is I'll scope out the building. I'll kind of scope out which areas are of interest and which ones are not. So it's easier for us to analyze, and also we don't show heat maps where we do not need them. Okay. So I'm just
I especially like to use scope zones like this, just to kind of constrain where we're visualizing coverage is. One thing that I've noticed over the years is a lot of customers get bothered by having Wi-Fi in the parking lot, but it's really difficult to provide a good experience inside the building, but not in the parking lot. So it's really best to just use the areas to just hide that, and that way it's just not so much of an issue, is what I typically find. So
exactly, I'll just mark out some of the staircases as well, and then I'll re-enable the heat map and the APs as well. There we go. So it's looking decent on 5 gigahertz. What about 6? It's almost identical in this case. The 6 gigahertz. 6 a little lower. You can see, for example, here in the border lines, we see a little bit more yellow, but it's not that significant, is it? And
no, it's not.
Certainly on 2.4, it's significantly stronger. And let's look at the channels. So I don't think the system even disabled any of the 2.4 capable radios at this point. So we could entertain the idea of disabling some as well, but for the sake of this exercise, probably not. Plus, it's not an ultra high density environment either. What if we change the AP type? Let's look at 5 and 6, and then we just change the AP type a little bit. Okay. What I'm gonna do is I'm gonna select all of these guys, and change them to 635 or something like that. Yeah, not that dramatic. There is a little bit difference depending on the antenna pattern, stuff like that. And you always want to design with the AP in mind that you're using. Oh, and we're looking at 2, 4, and 6 at the same time, so that's not good. So let's just look at 6 gigahertz. So 615, 655, maybe a little bit better with the 655, but yeah, there is some difference. So you always want to design with the AP in question, and then the system also kind of runs through the channel planner every time you do this. But anyway, you want to design with the APs that you're using, because there is difference clearly between the APs, maybe within the same brand, and if it's the same kind of high-end line of APs, there might not be that big of a difference, but there is some, right? So what do you think, Joel, for open areas or stuff like that? Are you a fan of disabling 2.4 gigahertz radios or no?
I am a fan of disabling 2.4 gigahertz radios, absolutely. And I think we still have to support 2.4 in many environments. Mm-hmm. Not all. There are some that we get to turn it off now, but I find that cranking down the transmit power, turning the transmit power way down, is not nearly as effective at just turning off unnecessary radios in 2.4 to reduce or really reduce interference.
Yeah. Like, as is what happened here. So I enabled disabling 2.4 unnecessary 2.4s, and in this area, because there's leakage also from other areas, but in this area where I kind of flooded it with APs, it actually disabled 4 or 3 of the 3 or 4 of the radios, because there's so many of those, and still we probably have some interference on 2.4. It's just unavoidable that there is some interference on 2.4. But if we did not at all disable the 2.4 radios, that would be more of an issue. Let's try it with enabling all of the 2.4 radios as well. And now rerun the algorithm, and we can see, yeah, it's definitely, even though it tried to rerun it a couple of times to kind of see if it gets better, but yeah, there's definitely a drawback there. Okay, so what did we learn about 2, 4, 5, and 6 for now? 2, 4, and 5 and 2, 4, and 6 certainly are different, very different from one another. But if we look at the differences between 5 and 6, there is a difference. There's certainly can be significant differences, but in typical environments, like, with lots of drywall, lots of normal windows, stuff like that, they're pretty similar, actually, in these cases. Okay.
And you see, Korea had some comments about transmit power in the 60 gigahertz band, and it's one of those things where they asked the question, and 5 seconds later we showed it on screen and it was answered. But are you typically are you kind of like me, where you're finding that just a couple dB more in the 6 gigahertz band is enough for transmit power to achieve pretty similar coverage? Do you tune that around at all?
That's the good question here. This was actually an unfair example, because in this case, unlike the soccer field, I did leave the defaults on. So it was 5 gigahertz on 10 and 6 on 12. So had those been kind of optimized properly, then they would have been almost identical in these cases. But yeah, for me, it's too early to say, but I would probably use a little bit more on 6 gigahertz than 5 gigahertz. But I think the jury is still out, and we still need more real-world data before I could call a good conclusion. What do you think?
Yeah, I'm pretty much in the same boat. I don't know that we know for sure yet what the transmit power differences are going to look like. 2.4 and 5 gigahertz for me are pretty easily. I'm usually somewhere around 6 dBm down in 2.4 and 10 dBm up in the 5 gigahertz band. But what I love about having a predictive modeling or a design tool available is I can mess with that, and we can play with it and say, like, okay, if we had to crank it all the way up to 14 dBm or something like that, could we do that? And what's that going to what's that approximately going to look like on the map? And so I love having a predictive modeling tool for testing hypotheticals like that, testing these what if scenarios, like what if the walls attenuate more than we thought they would. That's easy to change in a tool like this, and the same goes for transmit power.
Absolutely. And while we're on this case now, we deployed the Aruba tri-band APs here. How about we also utilize BLEs? Let's say we need to design this network for BLE location tracking as well. I know not everybody does that, but it does come up quite a bit, and at least the fundamentals probably we should cover of that. How about that?
Yeah, I think that's a great idea.
So let's look at first, like, how does this work then? The BLE radios are inside of each Aruba AP, and each of the like modern APs in general, I believe Ruckus, Cisco, Juniper Mist, and so on and so forth. So what we want to look at is BLE coverage based on what these APs are transmitting. But primary coverage isn't the thing for location tracking. It's usually the tertiary coverage. And here we get the issue, right? So I've set pretty stringent thresholds of neg 75 for yellow and neg 70 for green. These are very stringent thresholds for BLE tertiary coverage. But let's say that's the case. We want like super high accuracy location coverage. We want three BLE radios fairly well audible in every location. So we can actually augment this coverage provided by the APs by just deploying BLE beacons on top. So what I'm going to do is let's deploy BLE beacons at the default 0 dB transmit power, and we'll kind of put those in the rooms and see what comes out. We're starting to get a lot more of that tertiary coverage here.
And you see, just to be clear, the green is where we have negative 65. What's the threshold? Oh, we have negative 70 dBm from not one, not two, but three. We can hear 3 or more beacons from that location at negative 70 dBm or better.
Exactly.
Right?
So it's pretty stringent threshold, and we can see now we have a combination of BLE beacons and APs. And the beacons typically are not wired to the infrastructure, whereas the APs are. And why is that relevant? That becomes relevant when we start to consider switching. Let's say where do our 24 port 480 watt switches go? We might want to place one here and then another one there. And as you can see, none of the BLE beacons are wired into the switch, but of course the APs are. And if we look at the AP switch in more detail, for example, in this switch, we can see that only 4 ports are used, and still plenty of PoE power is used because these APs that we put in are 6 gigahertz capable, and they are fairly power hungry APs. So I think that's a major consideration in designing 6 gigahertz capable Wi-Fi. One of the major considerations, maybe the most important, is actually PoE draw. What do you think, Joel?
I agree. Planning for PoE budgeting is something that we absolutely have to do. And sometimes you have a team that does that for you, and that's really convenient. But every network design I've ever done, I've always been responsible for my own switching, my own port budgeting, and my own PoE budgeting.
Yeah, man, absolutely. And if we want to, at this stage, let's say it's a greenfield environment, and we know that these APs can actually be routed to different switch. Let's say I want this AP and this AP to also be routed to my switch on the left-hand side. I could just take that AP and say, instead of cabling that to the nearest device, let's actually cable it to switch number 18. You can see the routes of these APs change when I change this. You could also choose not connected if this was, for example, a mesh AP, or which is the case with BLE beacons by default. They are not connected by default. So we will just connect them, and you can see the dotted line looks different from the other dotted lines that go to the switch. Some of them are manually forced to the switch, and some of them use the logic of like just connect to the nearest switch around you. Okay, so now we can see there's 6 ports used and 250 watts still free of allocated power. And we get a rundown of here's your switches, here's all the cables that you need, and here's actually a bit of a problem, isn't it?
Yeah, it looks like your cable runs are too long. The APs are too far away from that switch, and so it might be a good idea to add another switch there.
Whoops.
Yep, there they are.
You think? Okay, well, let's fix that, and we'll put the switch in here, and it's looking a little bit better. Maybe one more here. And since we might also be deploying something that's not just switching or that's not just APs and BLE beacons, right? Things like client devices. And this is a pretty typical scenario for a systems integrator, that you actually deploy other things into the network yourself as well, that the customer wants. Things like security cameras that actually draw power from the switch. Or maybe you deploy just, desktop computers. Remember those with CRT monitors and all that? They may not actually draw power from the switch, but they're still a thing very, very much. So, Ethernet connected computers or non-Wi-Fi, or what was it called? Wired Wi-Fi computers. Cable Wi-Fi.
Cable Wi-Fi. One of my favorite examples of a client is desk phones. I like to throw desk phones everywhere because they don't have a ton of PoE usage, but they use up ports. And and Hamina will also tell you how you're doing from a port usage perspective. I've run out of ports on switches many, many times. So that's something that's important to plan for.
Absolutely, absolutely. And then you get that full rundown of like, okay, what did I deploy? What is my bill of materials looking like? How many APs? What type of APs? Also switches, cable, everything.
I like how you mix 2 different vendors for your APs there. I'm sure that's going to be fine. That won't cause any problems.
I think that's a different floor plan that I've earlier put in here.
Gotcha. Different building. We're trialing a different vendor there. Got it.
Exactly. Right. Okay, so that was kind of the bill of materials. And then, of course, the network design isn't complete without the customer being able to like virtually go on site and playing with the network deployment before it actually takes place. So we can take the roaming man, ask what the client device is. Of course, this you figure out when you're gathering the customer requirements, and then just see how the network would work from the client device perspective. How would it roam using an iPhone? Which band would it be connected to? For example, this iPhone, of course, never gets to 6 gigahertz, but if it's a roam at lower signal strength to a lower signal strength AP, there is the risk of connecting on this interference prone 2.4 radio, for example, here. But now since it connected or it roamed to an AP that had good signal strength at the time of the roaming, it actually was able to roam on 5 gigahertz, again, 5 gigahertz. But here, low signal strength roam, so roamed to 2.4, potentially a problem. You may want to address this by adding one more AP. Remember, we did a pretty sparse deployment, or you want to mess up with the transmit powers as well.
And what about a 6 gigahertz client device? What kind of experience are we going to see if we have something that supports Wi-Fi 6E?
Let's take a look. Okay, so here's an Android phone. So it does seem to prefer 6 gigahertz, at least some of the time. Now we're on 6 gigahertz, getting great data rates and all of that, still on 6 gigahertz. So there's definitely a preference on the Android OS to go on 6 gigahertz. Also, what the spec says and what we've seen is the Android phones do not have the tendency to grab onto 2.4 gigahertz on low signal strength scenarios as much as the iOS, which can be a plus or a minus. there's a chance that 2.4 is interference prone, or there's interference on 2.4. But then again, the iPhone can hold on to that 2.4 radio for longer and maybe provide a little bit stable connectivity. The jury is still out, at least on my head, with regards to that. But the Android is pretty 6 gigahertz heavy, as we can see from here.
I love seeing that data rate when we get nice and close to the access point, when we can hit a really fast look at that, a 4-digit data rate. That is weird. That's very cool, but very weird to see. Yeah. And you see, do we calculate higher data rates if you pick like a 100? I don't know if anybody's doing 160 megahertz wide channels in 6 gigahertz. I don't remember.
Great question. I think it should, right?
I'm totally throwing you under the bus here.
Does the Android phone support that? And does
I don't know.
The AP certainly does. So let's put 160 on the. Let's put it on all the APs.
If we're going to embarrass ourselves, let's be sure to do it in front of tons of people.
Yeah, that's totally fine. So we'll enable it for everybody. And here we go. And then we associate the guy again to the network. And look at this. Booyakasha.
It works. I did not know if that actually worked or not. So now, does the client support
everything
that?
Everything works on the product, right? Oh, wait.
Everything. There's no bugs. Hey, Korea has
Especially
another great
not
question.
Yesterday night.
Oh yeah, definitely. Yeah, yesterday there were no bugs.
The reporting definitely wasn't not working yet last night. Definitely not. It was working perfectly throughout last night.
All day yesterday, no problem. Yeah. Hey, Korea has another great question. So how have Hamina done the client roaming behavior simulation? Because phone vendors don't share their roaming decision algorithms. This is a cool feature, by the way.
This is true. What we actually have a black, well, is it black or dark gray? The van that we drive in front of people's houses, like in front of James Garringer's house. He works at Apple. We just drive the van there. First, we try to like eavesdrop him a little bit, but then if that doesn't work, we just hit him in the head on his driveway, push him into the van, and then we extort the information out of him. So it's a fairly scientific method that we've been using.
Mm-hmm. Yep, dark sunglasses, all of that.
Yeah,
but no, for real. Most of the time we don't have to resort to the white van and dark sunglasses technique. We're actually able to speak with a lot of the client vendors, and they were willing to give us information about how the clients performed. And in some cases, like with the Android phones, we were able to just peel open the Android open source project and look and see in the code, how do these devices decide when to roam? And so it's a combination of that and talking to the vendors directly. And we hope to add more. Yep.
Absolutely. And we are working with certain vendors to add their capabilities in here as well. And truth be told about Apple, they actually publish their roaming specifications. They are pretty much the only company that publishes like 2.4 gigahertz versus 5 preference, how it authenticate, what's the logic for roaming and things like that. That's publicly available information.
Yeah, so we only have to resort to the van method if they aren't available. So
exactly. So if you work for our competitors, here's how you design a roaming man feature.
Yeah. So, Jussi, do you have anything else you want to cover before we wrap things up? Yuri has some questions that he'd like to ask. But I just want to make sure that you've got to show everything that you wanted to show before we.
No, we did promise to talk about private cellular a little bit, didn't we?
Yeah, we did. Plus, it would be great to kind of complete the circle of we did 2.4, 5, and 6 gigahertz. We did Bluetooth. Let's do everything. Let's do private cellular so we can and wired. We did everything all at once. So let's finish it out, and then and then Yuri will take those questions from you here in just a couple minutes. Yussi's going to be fast.
I will be fast with this for sure. So for 4G and 5G private cellular, essentially it's about a few things. dedicated frequency. How much frequency you have available depends on the country, and also, for example, with CBRS, it depends on how much is available through SAS or the spectrum allocation system for you. If you, for example, are doing CBRS, you might only have certain channels, or you typically only have certain channels available for you. So let's say we have 1, 2, and 3 available for us on the 3.5 gigahertz range. Similarly to Wi-Fi, you select your AP model, the mounting type, and all of that, the transmit power. So it's not that dramatically different. We've also 3D modeled, these guys here, and instead of Wi-Fi, we just look at let's say RSRP for cellular, and we can see, yeah, it's actually quite a bit louder, but we are pretty loose on the requirements. So let's put some a bit more stringent requirements here. We can see that, yeah, that's how we would get coverage for the cellular AP, and usually the coverage is for various reasons, it is significantly better, but it's not magical unless you or magically different unless you go on some kind of 450 megahertz private cellular. But I don't know even where that would necessarily be a thing. But the deployment process is pretty similar. You would look at primaries, secondaries, SINAR, data rate, all of that kind of stuff, and kind of work your way through. And of course, the thing with private cellular is the way that signal SINAR works a little bit differently. So if you only have, like we here have a few channels available, between the APs, you will start to see gaps depending on the load on your network, but you will start to see gaps when SINAR starts to drop if your network load is high and you are forced to put APs on the same channels. So it's not so much of a traditional Wi-Fi CCI problem. It's just CCI is handled a little differently with cellular. So what you're instead starting to have is these gaps in SINAR, and you can a little bit try to combat that by placing the APs also differently on the map to kind of keep the interfering APs away from one another. But this is like a topic all of its own that we should probably cover more in a future presentation as well. But that's kind of how that would go as well. So Wi-Fi, BLE, 4G, 5G, all of that. What do you think, Joel? That's we pretty much covered the main things. Of course, when you're done with the plan, you can then push that into your favorite cloud-based management system. Just put in the API key, and the tool will automatically create the site, push the APs onto the site from the inventory, push the maps, push the AP locations. Kind of the entire site will be started in your cloud management system with a click of a button from Hamina. And so it kind of closes the loop on the whole thing. We didn't talk about reporting. We didn't talk about sharing projects with your colleagues, stuff like that. But maybe, if you're interested in knowing more about our phenomenal, groundbreaking, game-changing reporting system that's cloud-based, browser-based, dynamic, whatever buzzwords you can find, please contact joel@hamina.com or Jussi@hamina.com.
Awesome. Yuri, I think we're ready for those questions now, if you are.
Sure, definitely. Can you hear me? All right, so I have a couple of things here. First of all, that's fast and neat. I never see a tool so fast like that doing design. So that's very impressive. So what's your plan for general availability in Brazil? So that's available today if the guys need to purchase that. Can you say a little bit about that?
Yeah, I mean, it is available globally today.
Okay.
If you go to hamina.com, you can actually sign up to Hamina right away from here, and you can buy it on the spot if you would like, using credit card or invoice, or you can send us an email and we'll get you into the system.
Okay, and that's covered my second one. So what about the API support? Do you support API, or everything is like click today?
That's a good question. So what we do today is we actually utilize the other vendors' API, so nobody has to do any scripting. So click of a button, let's say the site goes into Meraki or Mist or Arista. And the typical other thing that people do with APIs is tampering with things like changing AP properties or that stuff like that easily. For us, it's just, you paint the APs that you want to change and you change them on the UI, or it's renaming the APs due to some kind of naming convention. And the naming convention for us is variable based, and we have an online tool there that tells you what variables you can use and stuff like that. So usually APIs or scripting for basic tasks is not necessary. But if anybody wants to use an API for one reason or the other, we're very happy to talk, and that we will have an API. We just don't have it yet.
Okay, perfect. And what about the internet connection? So it's required a lot of internet to work, or that's, let's say, if someone go to some place that does not have internet, that's going to work. It's a browser-based, it's a cloud-based. So can you explain a bit about that?
That's a really good question. The tool is what would be called very front-end heavy. So it doesn't need a lot from your internet connection. As long as you can, your packets go through every now and then, you will be okay using the tool. I've used it on airplanes and international flights, domestic flights, stuff like that. But you do need an internet connection for the planner. For the upcoming site survey solution, you of course do not need an internet connection. So if you're doing a site survey, then that will be synced to the cloud when there's availability.
And that's going to be actually my next question. So what about the wireless site surveys? It's on the plan. What's the roadmap for you? Can you explain a bit?
Yeah. Prototypes are currently running. So we like to say the site survey tool is available, but it's only available in Helsinki and Oulu, Finland. So but it's very close. So give it early next year. We will be coming out with stuff.
Okay. Sure. And are you planning to have a spectrum analyzer as well, or just site survey?
The tool will connect to actually various spectrum analyzers. So if you have, for example, a MetaGeek spectrum analyzer, you can utilize that with our tool as well.
And that's going to be, of course, it's planning and you're just have a roadmap, but it's going to be like based on the laptop, or you're going to have like external to capture the survey. So all the things going to work.
Great question. It will run on laptops, phones and tablets, and we will have an optional, like you can use third-party hardware to take the measurements, or you can use our upcoming measurement device as well.
Okay, perfect. And what about the export? I know you are excited to explain about export the design. So you generate like the PDF, a doc, how the things work, like to work as a team.
That's a great question. Let me just share my screen real quickly. All right, so if we go to here and we say create a new report generation takes exactly 0 seconds. So it's done. And what you have here is the possibility to upload a logo.
Sorry, you were not so sure yet. So you go to bill of material. Okay. Yeah, it's sharing. That's fine.
Yeah, this is the whole report here. So you have everything here, like the zones and the nodes and the floor selection. Here we can see that I actually had different floors here already on this project, but typically you would have one obviously per floor. Do I have something here that makes sense? I do. So you have the heat maps and everything, floor 1, floor 2, all of that. Primary coverage, secondary coverage. And if you want to hide certain things, no problem. You can easily hide those as well if you don't want the customer to see. And when you're ready for the customer to get the report, you can either create a PDF, or what we recommend is to share the dynamic report. So you just get the link and there you have the report.
And what about the retention? So how long time we're gonna hold this file? Like 5 years, as long as you have the license, how do things work?
It will be there forever unless you ask us to remove it.
Okay.
So
that's interesting. So let me see the next one. What's the hardware requirement for works fine? I see it's very neat and fast. So do I need to have a last MacBook available, or it's work in like old Windows 10?
The faster it is, the better. But a decent sized, laptop will do, and of course MacBook, Windows, Linux, even as long as it's not a Raspberry Pi. But all of those work. You can try it with your computer. The project I was working on, I have a MacBook here of last year or something, and the project I was working with had like a couple of thousand walls or something like that, and that was kind of the speed I got out of that. But I mean, even great laptops like the MacBook Air can be bought like with M2 can be bought for like 1,500 or something, and it's just blazing fast with that kind of hardware. But lower end hardware is okay as well.
And Nick has the same questions as mine. So what do you have against the Raspberry Pi?
We should try it. You see, I should dig out the Raspberry Pi 4 and try it and see what
that's going to be a very interesting test. Yeah.
The reason I say it is I've tried many times. I also tried configuring upping the GPU RAM of the Pi, because that was the problem. But yeah, it just don't go there unless you have too much time on your hands. I used like 30 minutes. I blew up a couple of Drew Lentz's computers while at it, and that was the end of my attempts.
Okay. And the last one is about the 3D radiation that you show in the beginning, like the apple, the pumping. So do you have that available in the tool, or is just like something you show us? We'd like to see like the 3D radiation that you show in the beginning, like show like the apple, something like that. It's available in the tool. Do you have each radiation?
Yeah, I mean the tool is fully 3D. We don't have the fancy looking
that's the one I'm talking about.
Inside the tool, but we don't have the fancy looking antenna stuff themselves in the tool. So certainly, like if you use different kinds of antennas and put them on different heights and stuff like that, that's possible. But the fancy visualizations for 3D are still waiting to be implemented, but they are certainly coming.
Okay, yeah, I think a lot of guys get impressed about that. So that's why we have a lot of questions. Yeah, I think that's it for me. I really appreciate your presentation. It was very good. I mean, everybody has a lot of questions, a lot of interaction. Do you have any final thoughts here?
No, I'm just showing the 3D-dimensionality of the whole thing.
Let me put in the stream back. There we go. Yeah.
So yeah, I mean, thank you so much for letting us present. And anybody who wants to talk more, my email is jussi@hamina.com, and Joel's is joel@hamina.com. So feel free to reach out. We're also on LinkedIn, Twitter, everywhere. So let's continue the discussion. And thank you to Mobility Brazil for putting up such a great event. I really appreciate you guys doing this for the Brazilian and Spanish-speaking audience. So thank you for having us over, even though we know exactly zero Spanish.
And we're really happy that you're here. It was a very high-level presentation. And feel free to put in the chat here your contacts for all the guys so they can reach you out. So your mail, your social media, that's fine. Thank you so much.
Thank you.
Bye-bye.